Hey everyone, this is Josh here for Deuces Cracked with the fourth installment of Applied Math, and I'm very excited about this video. I have a lot planned for it. We have some new OpenOffice Excel functions to show you, have a lot of explanations of continuing with this model and developing this model so we can encompass all possibilities. We're going to continue where we started from the last time, from the last video, and continue through next week's video, possibly even beyond that, and really modeling an entire hand of multi-street scenarios and being able to change around our constraints and come up with different EVs and compare them, and then take this model and hopefully be able to apply it to different hands that are similar. So you'll be able to save this and have this always, and the next time a similar situation comes up and you're wondering if, for example, maybe you want to check raise ace-jack on this board instead of king-jack, a hand where we don't have the gut shot. What can our EV, or what will our EV look like if we don't have the nut outs? So we'll get onto that, but for now we'll start off with that quiz that I left you with at the end of the last video. And the point of this quiz was twofold. For one, it was just sort of to make sure that you followed along and got accurate results. And two is just to kind of test out this whole idea of estimating and whether or not it's really worth pursuing or worth going forward with. So first we need to retie or retag the fold percent up to our calculated fold percent, because at the end of the last video we worked with goal seek. So it's 2.4 again, which is the result we ended up with the last time. First, before we go into doing that, we wanted to calculate the margin of error, and that required coming up with a new EV and saving our old EV. So if we just do it this way, we're going to lose our old EV. So we're going to calculate our new EV, and we need to still know our old EV. So we can, we want this to be this negative 2.4, but we want it to be exact. So we can copy, right-click copy, right-click paste special, and paste special numbers. So let's format it. So our negative 2.4. Could bold it. So next we want to continue with the estimating, and the method for estimating I provided was anything between 0 and 33 set to 0, anything between 33 and 67 set to 50, and so on. So the first first column we'll work with is the Cbetting column, and there's a couple ways of doing this. The first way is just the method by hand. The second way to do this would be to run an if statement. If the Cbet percent is less than 33, then make it 0. If it's between 33 and 67, make it 50%. If it's greater than 67, make it 100%. If we had a really, really long list of hands, that made it be the best way to go, and it would also prevent us from making any sort of mistake. But this is simple enough that I think we can just do it by hand. So the 95 goes up to 100, the 50 stays at 50, 75 up to 100, that stays to 50, goes to 100, the 40s go to 50, the 10% goes down to 0, the 75 up to 100. So something that is going to come into play is the fact that this 3-bet versus check raise, it only ranges from 0 up to 40, and even the second largest number is 25. So everything is just going to go down to 0 except for this 40. That just seems a little overboard in estimating. So we're going to try both methods in a moment. We're going to try a method of rounding to 5% and a method for just following along with this like I asked you to. And we'll see how much they vary. So first we'll deal with this one, and then we can go back and deal with that one. So we'll do this one the normal way. 0, 0, stay at 0. The 60% goes to 50. The 85 to 100. The 60s to 50. These all to 0. Then the 75 up to 100. And clearly the 99 is up to 100. So now, again, I had mentioned that first we'll try it the kind of the way that I first recommended doing. So where everything's going to be 0 except for that 40%, and it all works out. These all sum up to 100. So our EV, given this, or our change in EV, is going to be our new EV, as I provided here, new EV minus old EV, divided by the old EV. And that gives us a margin of error of 24%, and that's pretty bad. I mean, that's something that we shouldn't be willing to just accept for the sake of estimating. That's just way too far. It's going to lead us to making some fairly big mistakes, I would imagine. So if we go back, I'm just going to Control Z it. And we'll try this new method. We just had a margin of error of about 24%, so we'll try this new method of just rounding to the nearest 5. So the only ones that we're going to change looking at this are the 2% and 1%. Those will go down to 0. Everything else is going to stay the same. So for this, I mean, we can tell it looks roughly the same. And it's going to be the new minus the old divided by the old. Still basically the same, which is interesting. I mean, I guess the reason for that is the only thing that we really changed, or we just basically changed small percents there. But it is interesting that it's, I think, really the exact same margin of error. So, I mean, that just goes to show that this estimating method is probably a little dicey. It was something that I was open-minded to, but I think, excuse me, I think going forward we're going to probably do without that. Maybe we can try new methods, rounding to the nearest 10 and things like that. In general, I'll take this principle into account. In other words, I won't say like a Cbet percent is 73%, or maybe not even something like 70%. I'll try to keep it, maybe in increments of 25% or 10%, depending on the situation. So that was the quiz for this video, and I'll be right back with our episode 4 work. Before we begin with our spreadsheet and for the rest of this video, I would recommend downloading this spreadsheet just so we can get so you can get started exactly where I'm starting. I mean, if you kept up last video, then it should be similar. But it's tinyurl.com/am4kcjc, King Clubs, Jack Clubs, if that helps you remember it. What I'd like to do for this video is to methodically go and basically figure out not every, but just about every possible turn scenario. So first we have to figure out the value of hitting a 10, of hitting the nuts. Then we have to figure out the value of hitting a king, and then we want to see if we can profitably two-barrel on the turn, which would basically be all in with one pot-size bet behind. If we want, we can start adding in some, more creative thoughts. Maybe we can bluff the turn 1/3 pot, for example, and maybe that would work often enough to get him to fall at the bottom of his range. And that's kind of the beauty of modeling a hand like this is that now, or by the end of what's probably going to be the next video, you're going to have basically all the tools to model a hand and to experiment with different lines and to see the value of different hands, and then to take this model and change it to what if we had air? What if we had had a gutter with no overcard, or with without the nut, without a draw to the nuts? So there's all sorts of possibilities depending on the hand, depending on the situation, and depending on what you want to test for. So this will be the focus of this video, and it'll probably carry over to the next one, because it's a pretty involved method, and I'm going to try to go relatively slowly because there is so much to this, and this is when I think it gets really intensive. So yeah, let's get started. First, just like in the quiz answer, we need to tag our fold equity up to our calculated fold equity from the folded check raise percent. Another thing I wanted to mention that is that by the time we're done with all this, we're going to create a tab that's basically a control panel. We can edit any constraint, whether it be how often he's calling with top pair on a 10 turn, to how often he's continuation betting with different hands. And the beauty of that is that we'll be able to just test one thing at a time and see how the EV changes. We can even graph things, and I'm thinking about doing that because that's something I've done in past videos is create graphs, and that sort of gives you it helps you look at break-even points. It helps you just understand how the EV changes as different ranges change, and how drastically and dramatically it changes when these ranges change. So I have all sorts of ideas. But let's get started so we can actually get to those ideas. Now, something I like to do is create new tabs. It keeps things a little bit more organized, and I'm going to upload this sheet when I'm done with the video, and I'm going to edit it in afterwards. So you might have the tabs. I'm going to have to decide what the optimal way to get this to you is. But we'll right-click, add a tab after the current sheet. So it's going to give us just a new blank sheet. And we're going to lick them all out. So this is going to be a turn 10. We're going to turn the nuts. And we want to find out the value of that, basically the EV of that. So first thing I want to do is I want to copy over the, this is going to be our main table. This is going to keep getting copied over. So we just copy and paste. We'll deal with the, all these divide by 0 things. We're going to link everything back up. It'll be pretty easy to do, and we'll get used to it. So the things that we do want is we want the hands, the number of combos on the flop, which we're going to change in a moment. We want the strength of the hand, raise pre-flop, c-bet pre-flop. We don't care about the effective combinations on the flop because now we're all going to be on the turn. So we'll delete everything up to the calling range. So now we want to start linking them up, because this way, if let's say I decide that I want to change the continuation betting for sets down to 75%, I decide that I think this guy's going to slow play a little bit on the flop. So I want to be able to change this 75% and have this change in every subsequent tab, without having to just go and look for every spot where there's a c-bet of 95% and change it to 75%. So we can simply just equals, and then go back to the other tab and click, and then we can drag it down. And just to show you again for this next one, just hit equals, click to the flop tab, go to cbet, and it tags it syncs up. So like I said, let's say we would decide that on our main tab, on our flop tab, we would decide that we think he continuation bets 75% of the time with sets. So there it goes, it changes it. Now we want to sync up our check raise call. It recalculates, and now we just want to sync this back up. Now it's still tied to H45, so it's going to be all the way, maybe even on the other sheet. Oh, R45. I don't know, it's gone. And someone was nice enough to show me that Shift F4 locks in our tab, so it'll save us some time. And we can drag it down. Let's sum it up just to make sure it equals 100%. So basically, this is going to be this is just as simple as the flop range. We're not dealing with the turn 10 quite yet. So just to double check, the top one should be 16% of the call range, and the second one should be 11.4. So here's our 16% or 11.4. So we're good. Next thing we want to do is get rid of these strengths, because now we're going to be on the turn. And the turn will be, just to keep things a little bit simpler for now, the turn is going to be an offsuit 10. This is the type of thing that will make a pretty small difference. If say the 10 of spades, which can open up some, top pair plus flush draw hands and stuff like that. It's just going to make a pretty small difference. It's good to be conservative. So for now, when we're turning the nuts, we'll say that he won't turn a flush draw or like a combo draw. We would love it if he did turn a combo draw and we have the nuts. So we'll be a little conservative. It's always good to be a little conservative. The next thing we need to do is change the number of combinations, because the 10 does obviously change the number of possible combinations of certain hands, say pocket 10s. There were 6 combinations of pocket 10s, now there's down to 3. The other thing we need to do is we need to break up ones like this, where now pocket jacks and pocket 10s are very different hands. Pocket jacks are, an under pair with an open-ended straight draw. Pocket 10s is a set. So my method, which is not the only method, but this is just sort of my method that I've developed over time, is just to insert a row below the one I want to break up. The king jack and the king 10 are obviously very different hands, the king jack being the nuts now. Excuse me, ace jack and ace 10, different hands. The next thing we want to do is just break them up. So jacks, 10s, king jack, king 10 suited, ace jack, ace 10. And then we have our blanks here, so we want to change the blanks and the one above it. So there are 3 combinations of pocket jacks and 3 combinations of pocket 10s now, 1 card missing for each. For the king jack, there are still 9. 3 kings times 3 jacks is 9. The king 10 suited, we've got the king of clubs and the 10 of clubs accounted for, so there are still going to be 3 of those. And that actually didn't even change the number of combinations. So moving down, let's look for the next 10. Queen 10 suited, there is the queen of hearts, the 10 of clubs accounted for, that leaves 2. Jack 10 suited, there's the jack of clubs, 10 of clubs, that leaves spades, hearts, diamonds. There's still 3. 10-9 suited, there's 2 different suits accounted for, that leaves 2. Now ace jack, there are 4 aces times 3 jacks is 12. And there are 4 aces times 3 10s is 12. 10-8 suited, there's only the 10 accounted for, that's down to 3. So sometimes we can double check. Let's change this to turn. Sometimes we can double check, but this one it's relatively short, so that's okay. The next thing we need to do is take anything that's blank and then link it up to the one above it, because the jacks were with the 10s. The jacks and the 10s on the flop were effectively the same hand. As a result, we can just treat them the same, just by syncing it up. Equals the one above it. And we can just copy paste that very easily. So just to double check, the king 10 is linked up to the king jack as far as the flop play. Next, we can't just copy over the effective combinations, that needs to be recalculated. So we can just literally drag everything down. So this is all summing up correctly. Everything is linked, multiply the number of combinations times the pre-flop raise times the continuation bet percent times the call versus check raise percent, and that gives our new effective combinations, and this creates our new range. So this is our new range of all hands that call the check raise on the flop, all hands that actually c-bet and call the check raise on the flop, and then the number of resulting combinations given a 10 turn. So the one column missing here is the category, or the hand strength column. You know what? Sorry to backtrack. We're going to call this strength going forward. Just makes it, I think, a little more clear. And then we'll be able to group them together and treat them all the same when dealing with the raise. And that lets us sort of change around our constraints. We could say how often strong hands will call the all-in, how often medium hands will call the all-in. And we'll do that for each resulting turn card and each hand in the range. So that'll let us create that control panel that I was saying before, where we can just quickly change constraints without having to specifically say, ace queen versus king queen, which are probably going to be roughly the same calling percent. So I think aces and kings we can say are on sort of the borderline of strong and medium strength hands on this turn card. It's not a particularly good turn card for these hands. I mean, the pocket kings picked up a gut shot. Pocket aces are the strongest one pair hand when facing a raise. Probably not thrilled about it, so we'll call those strong. queens, tens, nines. I like to call nutted. I like to have that as a separate category, hands that are just never ever folding. It's good to distinguish that from, pocket aces, because pocket aces could conceivably fold. Pocket queens are obviously not folding. Ace queen, I think, is, it is weak enough relative to aces and kings that we can, say that's a little bit below the borderline to a medium hand. Pocket jacks have an open ender, so we'll call that medium. The set is nutted. The ace king's weak. The ace nine, I think, is below the borderline of medium to weak. Ace deuce is weak. The king queen I'll call medium. And honestly, if you would like, you can come up with your own categories of these and do it that way. Obviously I have no problem with that. This is just sort of my interpretation, and each person's interpretation is going to yield different results. So the king 10, second pair, gut shot. I think we can call that weak. King 9, call that weak. Queen jack is a medium, top pair open ender. Top 2 we'll call strong, not quite nutted. So yeah, jack 10, medium because it has an open ender. Jack 9, medium because it has an open ender, I guess. Bottom 2 is gonna be a strong, or middle 2 pairs gonna be a strong hand. You know what? I'm sorry. I'm actually gonna call the queen 10 suited nutted. I just can't ever see that hand folding to a shove. And that's basically my definition of nutted. Hands that will just never fold to a shove. This is clearly weak, 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 weak. And if you notice, these hands all have, they're 0% of the range, because these are hands that I'm saying will never call the check raise. Now, we could just delete them, but the problem is, what happens if later on we decide that we want to add in, some percentage of the time that he floats the check raise with ace jack or ace 10? And then, if that's the case, we want our whole table to respond accordingly. But we can italicize it for now, just so we realize that it's not something that's super important to deal with when it comes to equity and things like that. So now we have our resulting strengths, and what I'd like to do is create a table to tell me, first off, what percentage of each grouping, what percentage of his range each grouping is, and then from there determine how he will respond. So we can go strength, we can go strong, nutted, strong, medium, weak, and percent of range. And now I'll teach you a very simple Excel open office function. It's the SUMIF function, equals SUMIF. And it's basically saying, I want to know the sum of all of these percentage of new range if they say nutted. So now the syntax is this whole range of all the strengths, and I'll shift F4 it to lock them in, semicolon. Now I want the ones that say nutted. So I'll leave this one, I won't lock it in, because I want to be able to drag it down. Another semicolon, and now this range, the range that we want to sum up, and we'll shift F4 it to lock it in. We can change our format. We can sum them up to make sure they equal 0. Make sure they equal 100, and they do. So this looks about right. 22% of his range is always calling, 17% is probably usually calling, and then 53% may be variable. Let's add in our formats. I think the easiest way is just to copy 2 of these grayed out ones, so we don't have to do it manually. Paste special and paste our formats, and then let's add a border. So now we have our neat little table of hand strengths by percentage of the range. The next thing we want to determine is, well, how often is he calling a turn shove with each of these different hands? So let's say call percent. Let's say the nutted hands are calling 100%. I think that's the whole point of that nutted category. Now the strong hands are aces and kings and 10-9. I think it's safe to say those hands are usually calling. A check raise is classically a strong move, and then shoving 100 big blinds on a pretty coordinated turn card that could have made us a straight, or still gives us this set if we had it on the flop. It's going to make our range pretty strong. We're probably not bluffing that often on this 10. As a result, I would say he will call. I mean, he will fold. Our opponent will fold some percentage of the time. People are usually, I think, going to still call with these hands. So we'll say 80%. If you think it should be a different percent, feel free to change that around. The next grouping, medium hands, ace queen, pocket jacks, pair plus open ender, top pair hands. I think these hands are usually folding. Let's say 10%. And then we'll say for now the weak hands are always folding. And now, once again, the beauty of doing what we're doing and syncing everything up is that later on we can say, what if this guy's a calling station? What if this guy, always calls with his strong hands and calls with his medium hands 50% of the time? So we'll copy over our format, right-click copy, right-click paste special, paste our format, add a border. And now what we can actually do is, you're going to get a lot of Excel functions in this video. The next one is the sum product. The sum product is basically lets you do a kind of a weighted average. So if I want to know his overall call percent, I can just multiply and add. Multiply percentage of the range times the call percent, and I'll do it manually first, and then I'll show you the shortcut. So it would be the percentage of nutted hands times the percentage of the time he calls his nutted hands, percentage of his strong hands times the percentage of the time he calls his strong hands, and this is base theorem again, plus percentage of the medium hands times the percentage of the time he's calling with the medium hands, plus the percentage of the weak hands times the percentage of the time he calls the weak hands. And if we had a really long list and we wanted to do it for this whole one, then it would take us 5 minutes to do something that clearly shouldn't take 5 minutes. So this would give us a call percentage of 40.5%. And that's his overall percentage of the time that he is calling our turn shove. An easier way to do this is a sum product. Sum product. And it's as simple as dragging this one down, semicolon, dragging this one down. So it'll automatically multiply and add, multiply and add, multiply and add. And there's our 40.5%. So that's the sum product function. Very useful. We'll use it again when calculating equity. Now you're going to learn yet another Excel function, and this will be probably on my top 3 most useful Excel OpenOffice functions, and that's going to be the vector lookup. So we want to get our call percent based on the hand strength, based on here. And we could just go say, strong 80%, or strong, equals this one. Again, that's just going to take us way too much time. So there is the vector lookup, VLOOKUP. And we'll use this. I'll explain basically its syntax for this one, and then we'll definitely be using it again. So hopefully, the more we use it, the more you'll get comfortable with it, because this one can be a little bit tricky, and I've made mistakes doing this one in the past, definitely. So we want to look for strong. We want to on this table we want to find ones that say strong. So that's our first of 4 I don't know what to call them. It's the first of 4 things that we're going to put in this formula. The second one is going to be this whole table here. And we want to lock it in because we're going to be dragging it down. We didn't lock in the first one because we want it to carry over. Semicolon. And now the next one is the column that we want it to spit out for us. So we're saying if this says strong, then it finds the strong here, and now we want to know what the third column says. So we can literally just write in 3. Semicolon again, and we write false. So look how nice that is. it just spits out the 40%, I mean the 80%. We could just drag it right down, and look how easy that is. Now, for example, the 10-9 suited is strong, and it gives us the 80%. Now let's copy over our formats again with the paste special, add a border. So now we have our call percent, and let's come up with a new calling range. So as always, we have our percent. We want to come up with the effective combinations, and then we want to come up with the new percentage of the range. So the effective combinations are going to be, and as always, I like to just redo the whole thing. It takes a few extra seconds, but instead of just multiplying by the old effective combinations. So combinations times raise preflop times cbet times call check raise times call turn all in. Drag it down, and that's our effective combinations. We can format it. And then, sorry, we want to sum this up. And percentage of range. And this is all for calling the all-in. And we want to divide the effective combinations divided by this total of all the combinations. That's our whole range. And we want to lock it in with the Shift F4. We can drag it down. We can format. And once again, let's add in some nice headers and add in borders, and we can change this one to just be 2 decimal places. So now we have our new range. 32.6% of his turn all-in calling range will be aces and kings. 29% will be sets. Now, it's pretty interesting, and it just kind of goes to show how this works and how the weights add up, where if a hand is very, very likely on the flop, then even if he's seldom playing the hand that way in the turn, it's still going to be a reasonably large percentage of his range. So even though he's calling with sets 100% of the turn and calling with aces and kings only 80% of the turn, he's still going to have aces and kings at showdown more often, because it was just such a big part of his range on the flop. And even ace queen, which is only calling 10% of the 10% of the time, still has 6%. And what's that? The 1, 2, 3, 4. That's the 5th most likely hand for us to see when we get called. So we can decide, all right, maybe this seems like a little high, and we want to change now our aces and kings calling down to 75%. Let's sum it up just to make sure it equals 100, just to avoid any mistakes. And here we are with our new turn calling range. So this basically doesn't really do us any good. Right now, we know how often we're getting called. We know how much we win if we get called and how much we lose if we get called and we lose. The only question is, we're not always winning. Sometimes he has a set and he turns a boat. So we need to know our equity against each of these hands. And unfortunately, I don't have a shortcut for this. This one is a bit tedious. We're just going to have to copy and paste. So we have our flop in poker stove, queen of hearts, 9 of diamonds, 2 of spades. Our turn, 10 of clubs. We have king of clubs, jack of clubs. So I made it a little bit easier just to copy and paste. This is going to be our equity column here. So against aces and kings, we can group them together. Poker stove will take care of the number of combinations. And then we just copy and paste. We have 98.8% against that. Against sets. And we really could just do only queens or only nines or only deuces. It should be the same against all of them. We have 77%. Another thing we can do is just calculate our number of outs, or our opponent's number of outs, and calculate our equity that way. I find that leads to potential mistakes, and when dealing with so many numbers, you really want to minimize your chances of making careless mistakes. And even in some of these videos I've made, I think the last video someone pointed out to me that I did. It was very simply like ace 10 suited when we had pocket aces. I said there were 3 combinations. And clearly that's wrong. But if I had a way of just having the computer tell me that automatically, I would have saved myself the problem. Now sometimes poker stove is annoying, and it stops at like 83% and I can't paste. I don't know why this is doing this. Pocket tens, same as the other sets. Ace king. Ace king is 0% of the range, so we don't have to deal with that. These hands are 0% of the range. Next one is king queen. Now eventually, if we change and ace deuce, we change the weak calling hands to 5%, and ace deuce sometimes calls the turn. Then we're going to have to go back and plug in the equity, and we know this is 50%. It's the same hand. What's it called? Oops. Yeah. So if it's we might have to go back and plug it in if we need to, because we think those hands will be a part of the range. But until then, let's not waste our time doing that, because chances are ace deuce is not calling the turn all in, so we have no need to go out and figure out what our equity is against a hand that's just never calling. It's just waste time. I mean, this whole process is a bit tedious anyway. Once you get good at it, doing this whole thing may only take an hour, and it may seem like a lot, but I mean, this is a pretty common spot, and if we're able to, we're done now. And if we're able to take this common spot and really kind of solve it, and then from there we have this model for it and change it over to what happens on a different flop, or we have a different type of hand, then it's very possible to very quickly do it for different hands. So it's worth putting in the time to get this right, and to do all of these possible scenarios. So Bayes' theorem again, percentage of the range times our equity will give us our resulting equity. Some product of this one, of this column times this column, and notice how they'll match up, and that gives our resulting equity is 84% against his turn calling all in range. So now we have everything that we need. We have how often he's calling, we have how often he or she is going to beat us when we do get called. So we need an EV table. We want to know how much, what the EV is. We already had this table. Let's go back to the flop tab. Well, let's just copy this one over. Copy and paste it. It won't paste in very pretty, but we're going to have to change some things around. We need to sync this fold percent back up to the one on the flop. And now what this is going to do is, when we change the percents on the flop, and let's say he's going to call the check raise with pocket eights through pocket threes. It doesn't make sense, but what it's going to do is it's going to change oh wait, I'm sorry, I did that wrong. I would have to change this one to 0 because they're all linked up. So let's say he never folds the check raise with 8s and 3s, and he always calls it. It's going to change our fold equity to 52%. As a result, we want this one to change to 52%, and it does. So we can just Control Z it and change that back, because that doesn't make any sense. Let's format this one because it looks ugly. And now we need to add some some more possibilities in the table. So we want to add in the possibility that the turn is a 10, and we bet and we get called and we win. The turn is a 10, we bet, we get called and we lose. The turn is a 10, we bet and our opponent folds. So we want to go down 3. And we'll change this one to call. Turn is a non-10. He calls. Turn 10. He folds. He calls the turn. Turn 10. Calls. Hero wins. Calls. Turn 10. He calls the turn. Hero loses. Sometimes we can abbreviate, but I'm not going to do that. So first, let's deal with the the final stack. Now, The starting stack is still going to be the 96.5 because we're dealing with from the flop. That's still our perspective, still our frame of reference is we're starting on the flop, and we just want to add in now this possibility that we turn a 10 and the resulting stack from that. And this is the example that basically the first example maybe that shows why I like the starting stack method. It gets so confusing when you're just trying to figure out the the individual EVs of calling the turn, on the have him calling the turn when we turn a 10, when we already started on the flop, and trying to come up with the EV on the flop as a result of that. It just gets really confusing. So when our opponent calls, the turn is a 10, and then he folds to shove. That's basically the same thing as when he just... Actually, no, it's not. I'm sorry. It's as simple as our stack plus the pot. 68.5 in our stack, 66.5 in the pot, because we bet and he folds and we win the pot. So 68.5 plus 66.5, 135. When he calls on a 10 turn and we win, we stack him. So we get, oops, sorry, my buttons keep sticking. We have our 68.5 in our stack. We get his 68.5, and we get the 66.5 in the pot. So 203.5, that makes sense. We have our original 100 big blinds. We have our opponent's 100 big blinds, and we have the 3.5 big blinds that the small blind put into the pot. Both blinds enter the pot on the we're in the pot on the flop, so there's no blinds to add in. Now, we normally would do rake, and I mentioned that the last time that I didn't put in the rake. In future examples, we'll count on the rake. It is important, and I don't want to act as if it's not. When we get stacked, clearly we're down to 0. That's always the easiest one to figure out. Let's get it nice and even with the decimal places. First of all, we don't even need this 45% anymore. It doesn't apply anymore, because we need to, so now actually there's one more thing that we do need to know. We need to know how often we turn a 10. Makes sense, because the times that we don't turn a 10, we're assuming that we're just check folding and we're having 0 equity as a result, which is probably not true, but we'll account for that later. We definitely will. For now, we want to know how often we turn a 10. Now, it could be as simple as saying, well, there are 4 10s left in the deck on the flop, and there are 47 unseen cards. The 52 less the 5 that we've seen, the king, our king jack, and on the flop. So we could say it's as simple as 4 over 47, 8.5%. The thing is, we do have an idea of our opponent's range, and he may be more or less likely to have a 10 given that he's called a flop. For example, the chances that our opponent has a 3 are almost 0, or I think literally are 0. As a result, the turn is more likely to be a 3 than it is to be a 10, even though there are technically 4 remaining 3s, 4 remaining 10s, but our opponent may have a 10. So we can adjust for that, and it may or may not be worth it, but I think it's worth me showing you how I go about accounting for that. And it's going to be a little bit different than this 8.5%, maybe not hugely different. So we'll make a new column, average 10s remaining. When our opponent has aces and kings, there are always going to be 4 10s remaining. He has no 10s. As a result, there'll be 4 10s remaining, and as a result, we're actually more likely to hit a 10, because instead of 47 unseen cards, there are 45 unseen cards, and now instead of 8.5%, it's 8.9%. Same goes when queens, nines, and deuces. Same goes with ace, queen. Same goes with jacks. When our opponent has pocket 10s, there are only 2 remaining 10s. Keeping in mind that we're talking about the flop. We're talking about before the turn comes. With ace king, still 4, 4, 4, 4, 4. King 10 suited down to 3, 4, 4. Anything with the 110 is going to be 3. And this is the last one. The rest of these hands are 0% of the range, so again, we're not going to waste our time with that. Next thing we need to do is, we can't just average this. If we just average this, then it wouldn't take into account that 31% of our range, our opponent's range is aces and kings, and only 3.5% is pocket tens. So the next thing that we want to do is basically the same thing as with this equity. We want to do a sum product, because 31% of the time he's got 4, 29% of the time he's got 4, 6.6% of the time he's got 4. So we keep multiplying and adding, multiplying and adding, multiplying and adding, and finally we will get the average number of tens remaining in the deck. So we'll do a sum product of this column, semicolon, percentage of the range column. And as a result, we can see that there are 3.84 tens remaining in the deck on average. And since now we're basically saying we know what our opponent's cards are not unknown anymore. We know how many tens he has on average. So the number of tens remaining in the deck is 3.84 out of 45, not 47 anymore. So, in the end, for this particular one, very similar, 8.532. This one is 8.511. We're talking about a fraction of a percent, and you don't need to do this. I'm just calculating the margin of error. Oops. This is the accurate one. 0.2%. So really, for this particular one, it may not have been worth it. I think I'm gonna keep doing this in the future because it's nice to be accurate, and it only took me, explaining it took me maybe 2 minutes, and in the future we can go a little bit faster. So the turn is a 10, 8.532%. Then he folds 1 minus this 39%. So he folds, the 60% of the time he doesn't call. And please allow me to be a nit again, and I'm going to just format this because it was bothering me. I've made enough sheets where I didn't format anything and it got really hard to look at, so I think it really is worth taking the time to format it nicely. And when you print it out, you can look at it. And I do that from making the videos. I make my notes based on printing out the spreadsheets, and it's nice. The next one is the turn's a 10, and our opponent calls, and we realize our equity, our 84%. So it's this 8.53, turns a 10, and our opponent calls, and we win. So multiply those together. And finally, turn is a 10. Our opponent calls, and 1 minus our equity, so our other 16% of the time we lose. And now it's always nice to double check. If we add these three up, this should be the chance of the turn being a 10, and let's subtract it, and if this is 0, then we're good. I hope that made sense. Basically, we're just making sure that these all equal up to the chances that there is a 10. And then, since we know this has to all equal up to 100, we just want the chances that it's a non-10 just to be the the rest. And if we wanted to calculate it, then it could just be as simple as 100% minus the chances that he folds minus the chances that it's 10, and it should equal up to the same, 36.5, 36.5. So that's that. Now, as usual with our EV table, we can just drag down, make sure that this sums up right, and our EV is 4.5. Our EV on the flop was negative 2.4 given this, so this added some EV. So our EV given the possibility of turning the nuts minus our EV given no possibility of turning the nuts, no future equity, the difference is 6.9. Now there is another way to calculate this, and this goes under my principle that EV is additive. And EV is always additive, and you just have to know from what perspective to add it. So basically, this EV added is going to be the chances of turning a 10 times the EV on a 10 turn. So let's make a new table, and we'll show how that matches up. And for each subsequent situation, we'll match it up. And in the future, we may be able to save ourselves a little bit of time and a little bit of crazy EV tables by just adding in our different EVs and adding them together and knowing the factors to multiply them by. So let's take our EV table once again. We'll just copy and paste the header. Now, in this scenario, we are on the turn. We're saying, given that the turn is a 10, what is our EV of betting? So on the turn, we start with 68.5. That has to be our starting stack. And there's a few results. The first result is our opponent folds. We take down the pot. The second result is our opponent calls and hero wins. And then our opponent can call and hero loses. And that should encompass all the situations. Now, these are all out of this 8.52% or 8.532%, so we don't need to multiply it by that. This is all given that. So our opponent folds 1 minus this 39.7%. So he either calls or he folds. So when he folds, the inverse of that. He calls, we win the product of call percent times our equity. And then he calls, we lose the percentage of the call times 1 minus our equity. Sorry, I made a little mistake here. Do it one more time. Call percent times open parenthesis 1 minus M. Format it, add them up to make sure they equal 100. And they do, so we can go forward. When our opponent folds, these stacks are still going to be the same. Our opponent folds, where we have our 68.5 and the 68.5 in the pot, so 135. When we stack our opponent, we still get the 203.5 in play. And when our opponent folds, when our opponent calls and we lose, we get stacked. We end up with 0. Format. And then this is same old multiplying percent of the event times the final stack. Drag it down. Format. And then we have our average final stack, which we just sum up from above. Our EV. Have to make sure this calculates right, and let's make sure this one calculated right. Yeah. So the EV of pushing the turn is 81, and I mean I think that makes sense because we have the nuts. So obviously the EV of shoving with the nuts is going to be massive. But this only happens the percentage of the time that we actually turn a 10. So these are equal. Our EV, this equals our EV added. The EV of shoving the turn times the percentage of the time that we actually turn that 10, the percentage of the time that this scenario exists, is going to be our EV added over the scenario where we just always lose when we get called. So this just shows how when we get the knack of doing it down, that we can just add up our EVs as long as we know what to multiply them by. In this case, we have to multiply it by the 8.5% that we actually turn a 10. And what we can do is just test equals this equals that. If it says true, then they genuinely are equal. So that's good. The next scenario I'd like to cover is the value of hitting a king. And this is going to be similar. It's going to hopefully get a little repetition going so you're more comfortable doing this yourselves. I think I'm about 45 minutes into this video. The last one was like way longer than I wanted it to be. I'm trying for these videos not to be much over an hour. So and I think the plan right now is to leave you off with the quiz that will sort of test some of the things that you learned in this video, and we'll finish it off next video. So let's insert a sheet after the current sheet. Let's double click this so we can change its name to return king. And let's do exactly what we did the last time, which is start with this main table and just copy it over. The next thing we want to do is get rid of everything between Cbet and call the check raise. We don't care how often you 3-bets a check raise and so on. And if you recall, we deleted the category names because the turn is going to be different. And we synced up, the pre-flop raise to the pre-flop raise here. And we could drag that down. We can link up the Cbet to the Cbet percent and link that down. We could have also dragged to the right to illustrate exactly the same because they're right next to each other on the flop tab. Next, the call check raise. Let's link that up and drag down. And now let's just basically recalculate everything. Combos times raise pre-flop times Cbet times call check raise is our effective combinations. Let's drag it down just to make sure it's all right. Let's double click to make sure this sums it up correctly. And now let's just recalculate this one. Number of effective combinations divided by our new total combinations. Shift F4 to lock it in. Drag it on down. And let's sum it up to ensure that we're at 100%. Excellent. So now we've got our range. Once again, it's exactly what it was in the flop. And we're saying that the turn is going to be a king. Now, the thing about the turn being a king is that it's always going to bring up a flush draw. Whether it's the king of hearts, the king of diamonds, the king of spades. It's always going to bring up a flush draw. So I think sort of the fairest way to do it is just to because when the turn is the king of hearts, then there's no queen x of hearts possibilities. When the turn is the king of diamonds, then there's no 9x of diamonds possibilities. Pair plus flush draw. The queens are the most common in this range. The deuces are the least common. So I think the best way to do it is just choose the suit of the middle card. I hope that makes sense. It doesn't really matter that much, but I'm just trying to... otherwise, we'd have to say, what if the turn is the king of hearts? And do, calculate the EV. What if the turn is the king of diamonds? Then calculate the EV. What if the turn is the king of spades? Then calculate the EV. So I thought the best way to do it is just knock out the middle one. Split the difference, basically. So the turn is a king, so anything with a king we want to adjust for. So if you recall the method for the last time, we'll just add an insert a row, right-click insert a row, right below anything that we want to split up. So these look all the same. The jacks and tens are still roughly the same hand. The king jack and the king 10, is still roughly the same hand. Let's split these up since king jack is now chopping with us with top pair. Maybe it's a little bit stronger than the king 10. And once again, these hands we don't need to deal with right now. Let's italicize them because we won't waste our time because chances are these are always going to be 0. So now we want to adjust our combinations just for these ones that are that we created a new row for. So aces, kings. There are still 6 aces, but now there's only one combination of kings. The two case kings, king of hearts, king of spades. We're splitting up the king jack and the king 10 suited. There are there are 2 kings, 3 jacks. That leaves 6 combinations. And for king 10 suited, there are 2 kings accounted for. That leaves spades and heart. King 10 of spades, king 10 of hearts. The next thing that we want to do is find anything else with a king in it and adjust for that. For example, ace king. Now there's only 2 kings unaccounted for and 4 aces. That's 8. For the king queen, 2 kings times 3 queens is 6. We did the king jack, we did the king 10. For the king 9, diamonds and clubs are accounted for, and those are the only kings. Now, this opens the door for flush draws. Any hand that can have a flush draw, we need to add in a new row for. So it's just basically the suited hands, except ones that have a 9. So this ace 9 cannot have the flush draw because there's the king of diamonds and the 9 of diamonds on the board. Ace deuce of diamonds can be a flush draw. King 10 of diamonds cannot be. King 9 of diamonds cannot be. The queen jack, the queen 10 definitely can be. Queen jack of diamonds, queen 10 of diamonds. Once again, I really hope this all makes sense. I mean, basically, when the turn becomes a flush draw, we have to separate regular old queen jack from queen jack with, pair plus flush draw. So the jack 10 turned the nuts. Honestly, doesn't really matter. King jack of diamonds may be more likely to slow play, but let's not get too crazy about this. So remember, anything with a 9 can't have the flush draw. So these are the only flush draws that there can be. Queen X of diamonds and ace deuce of diamonds. Once again, let's change our combinations. Since there's only one combination of each flush draw, we just basically take it off of that. So there are 3 ace deuces normally. Let's change that to 2 and 1. There are 2 queen jacks normally. Let's change that to 1 and 1, which would be the diamonds and the spades, because the queen of hearts and the jack of clubs are accounted for. Queen 10, they're normally 3, so we'll do 2 and 1. So we have that all accounted for. Our new combinations are calculated. We have not dealt with these ones that are at 0%. If for whatever reason we want to add that in, we're going to have to come back later and fix these things. Let's say we do think that the ace 8 suited through ace 3 suited will float the check raise sometimes. If that is the case, then we have to say, all right, well, this hand made the nut flush draw sometimes. Very, very unlikely, so we're not going to deal with it. Next thing we need to do is we have these open cells here, so we want to plug something in for them. Once again, as was with the last one, we can just tag them to the one above it, because we know the kings are going to respond the same way as the aces on the flop. We know the ace deuce of diamonds is going to respond the same way as the ace deuce of hearts. So we can just copy paste, copy paste, copy paste, and it's going to tag in the formula just to equal it to the one above it. And then we can just really just drag these right down. There are fewer combinations than we started with, which makes sense because now there's then there's another king accounted for, and there are fewer pocket kings, fewer king queens, fewer ace kings, and so on and so forth. So now we have our new range calculated, and we need to categorize. That's the one column that's left blank. So I would say this card is going to be similar to the 10, and we don't want to make too many major differences. So when someone has pocket aces and the turn is the king versus the 10, maybe not a huge difference. The big difference being that the major draw that we're check raising here, or the number one draw that we're check raising on the flop, is Jack 10. Jack 10 got there. So our opponent may be less likely to call, but we'll still call aces strong, though it's very, very borderline. We'll still call kings nutted. They're never folding, and that's, like I said before, that's what nutted means in for the purposes of this. Ace queen no longer has top pair. We could say this is a medium hand. It's almost weak at this point. The jacks and the 10s, they have a gut shot. We could say it's a medium hand as well. It's very unlikely to call, though. The ace king, if ace king happened to have floated the flop, I think this logic's okay. If ace king happened to have floated the flop and he turns a king, I don't think he's just going to consider it a medium strength hand. He's probably likely to treat it similarly as if he had aces. So with that, ace 9's weak. Oops. Ace deuce is weak. Let's ignore the diamonds for now. Top 2 is strong, maybe not quite nutted. top pair with a gutter, we'll call medium. Top pair with the gutter, call medium. Two pair, call strong. Just the regular queen jack with a gut shot. I guess we can call medium. It's probably similar to having the ace queen. It's unlikely that, you know, if anything, it may even be better to have this hand than ace queen, because if ace queen is ahead, then queen jack is probably also ahead, and queen jack has more outs when behind. So, like I said, we'll ignore the diamonds for now. The queen 10 is medium, same as the queen jack. Jack 10's the nuts. Jack 9, I think we can call weak. 10-9 weak. 9-8 weak. And then we'll leave these blank because, again, we're proceeding under the assumption that these are probably always going to be 0. I think I filled them out last time, but yeah, we didn't. I mean, honestly, we could just leave it blank. And for the 10 tab, I won't change it, but yeah. Now this leaves us with the diamonds. So I'm going to call these combo draws. You know, this is the reason I left it for last, is we're kind of introducing a new you know, set of hand strength. So we'll make our table of hand strengths. I'm sorry, let's put it in C. There's nutted, there's strong, there's combo draws, probably between strong and medium, and then there's weak. And again, we can do our sum if. I think it'd be a good idea for you to test yourselves if you're not familiar with the sum if statement and see if you can get it to work now. You can pause the video to do that, otherwise I'll continue in a few seconds. Alright, I'm just going to go ahead, sum if. This column, we want to shift F4 it to lock it in, semicolon, nutted, semicolon, new range, shift F4 it to lock it in. Since the nutted is not shift F4, since it's not locked in, we can just drag it right on down, change our format, sum it up, it should equal 100, and it does. We can call this percent of range. Once again, we'll copy for our format, copy, paste special, format, add some borders. So 19% of our opponent's flop calling range on a king turn will be nutted. 29% will be strong. About 4% will be combo draws. 44% will be medium strength hands. So when we've turned to king, I think it's safe to say that betting is probably not the best play. We have that hand, like I talked about in, you know, I think the second video, or maybe even the first one, the hand where all better hands are calling, all worse hands are folding. We are far enough ahead of hands like Queen Jack that it doesn't make sense for us to be betting sort of protection. If there was 20 big blinds left in this, you know, 68 big blind pot or 66 big blind pot, then maybe it would make sense, and it probably would make sense just to put the rest in for 1/3 pot, protect your hand, just get stacks all, and you can get called by worse. With one pot size bet, I do not believe that to be the case. If you'd like, you can definitely experiment with that. I'm confident enough that betting is no good that I think we can operate under that assumption. If you'd like me to explain that further or assist you in testing that, I'm happy to do so. And you could post in the video thread for help. So with that said, we're checking. So what we need to know is our opponent's betting percent. So let's say when he's nutted, when he's got a set or he's got a straight, maybe occasionally he'll slow play, but on a 3 straight board where we just check raise the flop, I think he's probably likely to just go all in. With the set, you know, with Jack 10, maybe he would slow play sometimes. So let's say 95%. Maybe that's high. If again, I mean, you know, this is just my opinions, and if you'd like to put in 85% or 90% or 75%, then you can feel free and see what your results are. So when he's got his strong hands, pocket aces, ace king, we check to him, king queen. I think he's very likely to go ahead and bet. It's those hands are all vulnerable, and those hands are pretty likely just to be ahead at that point. So I think they're very likely to bet. Let's say 90%, 10% of the time he pot controls it. With combo draws, I think if he's got a queen, he may opt not to bet because probably only getting called by better hands technically, probably not bluffing any hands out. I mean, maybe we could fold ace queen if he shoves in with queen jack. Some people will just shove there anyway because they have enough equity, and I wouldn't necessarily have a problem with that. So let's say, and I would say like the ace deuce almost certainly shoves there. So let's say 50% of the time he shoves, 50% of the time he checks. If this is where the differences do matter. Like if the turn was, say, the queen of hearts, for example, now our opponent can have ace nine of hearts, ace deuce of hearts, 9-8 of hearts, 10-9 of hearts, all of those hands, and those are more likely to bet when checked to than are flush draws like queen jack. And if the turn was the king of hearts, then there would be no possible queen jack with a flush draw. But it's only 4% of his range, so it's it's a small factor. Now his medium strength hands, these I think are the hands that are very, very likely to pot control. The hands where he's probably content to check it down and get it to showdown. So I'm going to say he's going to bet it only 10% of the time. And the weak hands, these are just pure bluffs at this point. Maybe semi bluffs in the event of like a 9-8. I'm sorry, it's like a 10-9, a pair and a gut shot. So let's say he'll bet 5% of the time. Oops. Let's add our borders. Change our format. And once again, we can do our sum product of this column, semicolon, this column, and it will give us the percentage of the time that our opponent bets when we check to him or her. So what I'm going to do now is I will fill out the columns for bet percent and effective combos of bets, percent of bet range, and equity, hero equity, and then check percent, effective combinations, percent of check range, and hero's equity against the check range. So what we'd like to know is from this, when you fill in this table, you'll have an idea of hero's equity against the betting range, which is important because we do want to know, for one, under what circumstance should we be calling a shove. We'll be getting about 2 to 1, so do we have our requisite about 33% equity against our opponent's betting range? Can we, let's say we play around with our range, let's see under what circumstance we should be check calling after we check raise with the king jack. Because I think that's something that often comes up that maybe is something we don't think about, is when we do check raise with this hand, and we're thinking mostly about the gutter. And maybe sometimes we even add in some outs for having that overpair, but it's going to be tough to play. And should we be check calling with it? We know we shouldn't be betting with it. Should we be check calling with it, or should we just be checking and hoping to get it to showdown? So my assumption here is going to be that when our opponent checks, we're just going to check it down to the river. There's so many possible river combinations. I think the easiest way to account for this is just to assume that we realize our equity. In other words, assume that if we're ahead 50% of the time against our opponent's checking range, that we're going to win at showdown 50% of the time. No money will go in the river. It is definitely not the truth, but it's probably not that far from the truth either. And I'm going to format this. with the borders. So I'd like for you to fill in this table and to calculate the bet percent. I'll make a new table of things that I'd like you to solve for. Bet percent of the check percent of the equity versus bet range, equity versus check range, and from there, next week we'll start calculating the EV of turning the 10. How much EV is that adding to our range? The fact that we do have this overcard. Now, if you're feeling motivated, you may feel free to calculate that EV. But I think for now, the best way, or we can just stop it, filling out these tables, because that'll sort of force you to rehash everything that we've done, or most of what we've done in this video. So we'll conclude this video here. Hopefully this one wasn't too long for all of you, but I think this was like the first video where we really started getting into the details and filling out these tables and showing you all the tools that are necessary or are available to you to solve just about any poker example. And we'll finish off next week with the rest of this example and come up with this whole all-encompassing dealing with the turning straights, turning top pair, turning whether or not we should be bluffing, and putting that all together and having make sort of like a dashboard where we can change around our constraints and seeing what it takes for this to be a positive expectation play. So thanks everyone for watching, and especially thanks if you were able to follow along with all of this. And as always, comments and questions are very much welcome and appreciated. So thanks again for watching. It's been Josh for Deuces Cracked.